Good morning. Welcome to my Tech Talk webinar on the ASA and AnyConnect VPN. I'm Rick Williams, and I'll be leading this seminar over the next, it took me a little over an hour yesterday, so we'll see how quickly things go today, but welcome. Please indicate to me through chat or what have you, the icons you have available to you to let me know that you're okay with audio. If you're having any problems hearing me, please let me know as soon as possible. Okay, let's go ahead and move on. So once again, welcome. A little bit of an introduction for what we'll be covering today. First off, with myself, I'm Rick Williams. I've been a certified Cisco instructor since 1999, and it didn't happen in '99, but shortly after, quickly became interested in the Cisco security products that were available. Not many at that point, and over it was a long time ago. Over the more recent history, I've been rededicated as a Cisco instructor towards security products, and over the last 2 years, I have gain and teach actively classes on the ASA. There's two product training classes on the ASA that I teach. My most popular and most frequent class is on the Identity Services Engine. Was also a product training class until it got added to the CCNP security track. I also teach two product training classes on firepower, one on firepower threat defense and one on the firepower IPS aspect. And those are both now added to the CCNP security track. So some of my background. And then my hope today is to demonstrate setting up an ASA with a publicly trusted certificate. So this is, in fact, our sunset production certificate that we use for our lab environment, which I also, over the last years, have been a large participant in terms of the setup of our voice, collaboration, and contact center lab environment. I'm the principal designer and engineer of that lab environment. And so we're taking advantage of some of that architecture for this demonstration today. And then the audience is meant to kind of help people out that are just starting out with the ASA and folks that might be trying to make things work in a more production environment. One of the things that I run into most often in my class when it comes up as a topic is what I'll call anxiety around public key infrastructure. What the heck is going on there? And some of it, I would blame on the devices, appliances, systems themselves in terms of the application of a certificate. It just, the terms are not consistent, and what's going on is not immediately apparent. It's not intuitive. And so much of the focus of what I'm demonstrating today is about that, is what's going on with PKI. We'll do a little bit of a review of that. Then we'll move into practical aspects, things that are difficult to extract out of Cisco course content, the typical requirements in a nutshell. What do we need to get this done for real? And then we'll step through the installation, get that publicly trusted certificate installed on the ASA, and then we'll apply ASA tactics using the ASDM to set up a remote access VPN and apply that certificate that we just installed. Then we'll kind of review what just happened, what all went into the config, and then test access. If not immediately apparent, I'm sitting in my home office environment. The equipment that I'm manipulating is sitting in our Denver lab environment. The access that I'll be testing is with a VM on my laptop here at home, utilizing the public internet, public DNS, and of course that publicly trusted certificate, and we'll test that out. And then based on having a functional environment, I think it's important to discuss backing that up, particularly where that appliance, that ASA that we just set all this up on, is a physical device and can break. And when that happens, we want to make sure we have some means of recovery to be able to apply that same config on an alternate device. So I'll demonstrate that as well. And then open up things for a question and answer. The little bit of a unusual circumstance. I'm going to draw on content from another class that I also taught in recent history. Unfortunately, in my opinion, Cisco has expired this course content. This is IINS, the title, Implementing Cisco Network Security. The IINS course content was developed to assist people with the now also expired CCNA security certification. So this is a really nice class for folks initially stepping into security. Also provides a nice introduction to the ASA, and I hope we'll bring some of this back. And so I'm kind of bringing some of that back right now. Just real quickly, again, this idea of public key infrastructure, what the heck is going on? Encryption. That's I think everybody thinks about that aspect. Some of what we're gaining by PKI's security and encryption is definitely a big part of the game. And I think most folks, when they think about encryption, they're thinking about symmetric encryption algorithms. So yeah, shared key. What the typical aspect of a symmetric encryption algorithm is that we've got peers on one side or the other that have a common key value that they can use to encrypt and unencrypt or decrypt, whatever term that you like to apply there. And the match key values are that's what's important. And this is the most common means when we think of a tunnel or encryption, that aspect. This is the most common tactic that's used, is we've got a key that's applied and we use that identical key to get those contacts. The algorithm, when we think of something like a VPN tunnel or an IPsec tunnel, this is the way data streaming is done, computationally efficient, as they point out. Challenges, which are not apparent on this slide, are that the key itself is the most vulnerable aspect to this particular tactic. So we want that key length to be very large as we can. They point out we can get up to 512 bits there. And then we don't want it to last very long. The longer that it's in use, regardless of its length, the more likely that it could be compromised. So one of the difficulties around symmetric encryption algorithms is establishing that key value, that common key value on both sides temporarily. So we have alternate algorithms that are applied here based on Diffie-Hellman, and Diffie-Hellman will exchange bits of information between the two peers, and ultimately the two peers can establish an identical key value on each side. This is done naturally as part of SSL and TLS-based interaction. So the method for establishing those key values is the same on each side. And then, yeah, some of the common symmetric algorithms, triple DES, AES, those are symmetric, where we use a common key value on each side. And then moving on to more now the basis for public key encryption, this is substantially different. In this case, we have two different keys. They show improperly an encryption key, and it's really about private and public, and really can be a function on either side in terms of how we establish that. And we'll see some of this coming up here. But the idea is that we have alternate keys that are mated together. In this example, we see Alice on the left, Bob on the right. Alice has a copy of Bob's public key. Bob, of course, has the mated private key to that key pair. And they are mated together for all intents and purposes in terms of the application that's being used. The private key part of the key pair is never divulged. In fact, on most systems is difficult to even get a visibility on for normal human beings such as ourselves. The public key is handed out to anybody that needs it. So indiscriminately handed out, in effect. And now Alice can use Bob's public key to encrypt information and Bob can safely decrypt that information with the mated private key. And what's not immediately apparent now is that Alice has some faith that only Bob can decrypt that information. This is the benefit. And it works in both directions. They try and describe that here. It's more about, and I'll flip back to the previous slide, it's more about the idea that the encryption aspect works in either direction, both directions, and this is also always done. So when Bob is sending information to Alice, and we can say she's receiving information, that information is also encrypted with the private key, and Alice can safely decrypt that with the public key. This is, again, normal part of SSL, TLS operations today, this aspect. Where we're seeing that demonstration, it's used primarily, and I'll flip back just once more here. They point out that one of the difficulties with asymmetric encryption is computationally expensive. So not used for data streaming, but often used in as part of, again, typical TLS session-based activity that we're using it for authentication, that we use asymmetric algorithms to identify each other. And so, yeah, a little bit of a example of how this can be done. And there's so many methods that provide these overlapping tactics to provide security and authentication. Here we're seeing clear data that we have ran through a hash algorithm, and that hash algorithm is provided a fingerprint or thumbprint, a hash of that clear data. And then we take clear data and the hash value and encrypt it with the private key and send it out. And in this case, there'd be an idea that we're completely, this information as we're transmitting it is completely encrypted by virtue of the encryption with the private key. And so now any recipient of the mated private key can unencrypt that data, and along with the clear information inside, also retrieve that hash value. They take that clear data and run it through the same hash engine, and if they arrive at the same hash result, that is good, valid, non-manipulated data from the perspective of the recipient from the sender. And that further, by virtue of this private key ownership, that we now know for sure that the left side is the actual sender of that data and not some other sender. Now, one of the things that's not immediately apparent is that for the private public key pair and the basis of encryption that it provides, one of the downsides of it is that it's not immediately apparent by virtue of looking at just the public key who owns the other side, who owns that mated private key, who actually sent this data. So the third party example, this is part of the, again, the basis for PKI, that we see the example of the driver's license. We go to the driver's license DMV or what have you, provide sufficient example of identification, birth certificates, other concepts, and then we get a driver's license from the DMV. And then we can use that driver's license to use for identification purposes. Yes, I am who I say I am. Here's proof of that. And now you can cash the check that I'm trying to write. And so this is the basis of PKI, is to take that public key value and provide identifying information on it. So public key infrastructure, let's put in effect an envelope identifying information around that public key, and then provide a stamp of approval, a validation. So the third party, in this case, this is the CA or certificate authority, other terms, the root. And then not listed here, that is also common, we'll see this in my demo coming up here shortly, is that there are subordinate or intermediate CAs that are in effect acting for a proxy for the CA, offloading some of its work. So we distribute that through public key infrastructure and provide subordinates or intermediates to the actual CA. And then, of course, the identifying certificate itself. Lots of standards around this. Cisco adheres to these very well. So in all these demonstrations, outside of the fact that it's an ASA and AnyConnect and in aspect, we get to see some Cisco bells and whistles there. Ultimately, it's all based on non-proprietary standardized technology. And then what we expect out of the envelope. So the fields that are provided within the certificate, we've got version, serial number is a key aspect. We use that for validating against the CA. We can query the CA, is this serial number still valid? Has this certificate been revoked? It also describes within the envelope the algorithms that were used to establish the contents of the certificate. So identifies the SHA fingerprinting algorithm, which variation of SHA, for example, do we use? Who the issuer is. So this is our CA or potentially a subordinate CA who provided a stamp of approval for the certificate. And there's a signature in effect involved in this signing. We've signed this certificate and the issuer is also listed. Validation period, also important, that there's an expiration. And this is established as part of obtaining the ID certificate. And then we've got identifying information that establishes who we are. So the subject, often, again, different values that provide subject information. CN is one of the most common. A great slide for this. So in terms of establishing a public certificate, we're communicating with some vendor provider on the internet. In our case, for our publicly trusted certificate that we have at Sunset, we obtain that from Entrust, but there's VeriSign and GoDaddy and a large variety of vendors, different pricing, different tiers. Fundamentally, it's about how many entities I'm trying to provide identification for. So there's a variety of certificates based on that. Subject alternative names that can be listed in this one certificate. I can apply on multiple devices. Could be just for one device. And of course, the certificate that I'm using is a wildcard certificate, so it can be applied to many devices. The other aspect of obtaining a certificate is the term. How long do I want that validation period to be? They're showing up POTS, a phone call communication going on. Yeah, it's effective out of band. So I'm communicating with Entrust primarily over email. I establish the type of certificate I want, the term, and pay the money that they need, so funding required. And then they do, I have to, as part of the operation, provide information about my organization and other individuals that work within it to provide trust that I am authorized to do this operation. So Entrust communicated with Sunset CEO, my immediate supervisor at the time, and he said, yes, Rick Williams is authorized to establish this identity certificate on behalf of Sunset. So there is usually a couple of other steps there. This is in anticipation a day or two to get your official identity certificate. And then there's an operation. Once that validation, you were authorized, the certificate authority, Entrust in this example, needs a certificate request, also known as a CSR or certificate signing request, with all the information that I need to identify ownership. The CA then provides a signed digital certificate with that identifying information in it, and of course the public key with my private key pair that I can distribute easily. And now the idea to establish the same level of authentication and security is that I can hand out my public certificate. I'll be Bob in this case. I can hand that to Alice. Alice can hand me her public certificate, and we can each authenticate one another, understanding that when we use the public key half of that key pair for encryption, that only the private key pair peer can unencrypt it. And we can safely send secure data back and forth between one another. In this case, simple authentication is occurring. Revocation important. We mentioned the serial number and that we can query. There's different tactics for that, CRL, OCSP. For our ASA AnyConnect VPN environment, not super important. Important over in the overall infrastructure, but not super important in terms of checking revocation. Just that signature. Do we trust that signature? And in this case, here we're seeing, yeah, the use case, SSL, TLS. This is where we really like to see public private key aspects occur. And in this case, this is general. This is generic web browsing, AnyConnect to an ASA, same things are occurring. So the user makes an initial connection to TCP 443, and upon that initiation, the server or ASA headend provides that identity certificate that was signed by the certificate authority, and of course has that public key value in there. The endpoint, the other side, validates the information within that envelope. Is there identifying information in that certificate with respect to the entity that I just contacted? So I'm looking for that match, the FQDN. Did I browse to this? I initiate connection to this FQDN. Is that FQDN in the certificate? So that's validated. Of course, the validation period, and then ultimately the signature. Who signed and provided the certificate, and do I trust that signer? Once that's done, there's another process that occurs. This is where Diffie-Hellman kind of kicks in. The two pairs share information between one another, and a common symmetric key value is established through the Diffie-Hellman process. And once that symmetric key is established, all further data communications, data streaming, bulk encryption, as they demonstrate here, occurs using a symmetric algorithm. Now we're not using private public key. Now we've identified and authenticated one another. Now we can, and we use that security that was in place by the private public key algorithm to establish a symmetric key value that we now use for bulk encryption and data stream. And this, yeah, notice they're not, they're pretty good on the slide here. Yeah, it's not a web browser and web server, not just an ASA and AnyConnect client. This is effectively universal to how SSL TLS functions today. A little bit about key management and key spaces, and let's kind of move back to the program here and talk about requirements to get this done. Very important that the ASA that we're trying to establish this identity certificate on has current and fairly accurate time. We're trying to establish things based on that validation period. So if the ASA is booting up with factory default time, if you will, which is pretty hard to achieve today, honestly, but nevertheless, we want the ASA to have understanding of current time so that it fits within the validation of the certificate that we're ultimately going to be able to ultimately provide for. For PKI overall, yes, this is an important concept. So best done with NTP. Again, accuracy is not necessarily the important thing, but currency, if that makes sense. And then AnyConnect files, and kind of fitting within this AnyConnect licensing. Today, this is all done with SmartNet. And for most, in fact, what I'm demonstrating today, and if I recall correctly, the license type that's needed is AnyConnect Essentials, and then we need to acquire a quantity sufficient to cover our cumulative concurrent number of users that will be accessing the ASA with AnyConnect. Smart licensing makes this very easy. It's all term-based licensing, so I can say, I think I'm going to need 20, but they'll let you exceed that threshold temporarily, because that can happen. And the terms can be from 1 year to multiple years, and so we can fluctuate that size of licenses that we need, and that multiple ASAs can draw on that pool of AnyConnect licenses. So Smart License makes this very easy. Up until you acquire an AnyConnect license, you will not be able to download the AnyConnect files that you need for this aspect. So outside of the ASA that you physically have, still need to obtain AnyConnect license outside of the 1 or 2 that are allowed by default, and this is what I'm taking advantage of today. And then now we've got AnyConnect license. We can download things. 2 types are needed: the deployment package, head-end deployment package, and the pre-deployment package. I'll go ahead and take advantage of this link here to show what I'm talking about. And I won't log in here. I don't need to log in to show this, but just clicking on this file information column header, I can see deployment package, which shows a .pkg extension, in this case for Linux. And then down further along, there's AnyConnect installer and pre-deployment packages that are listed out for the various operating systems. And again, minimally needed, absolute necessity is the PKG file that we're applying to the ASA, and then the pre-deployment package is handy where we want to look at alternate means for getting the installation done. Again, in terms of planning ahead, we need to consider the fact that we're adding to our network with our VPN clients and effectively extend. We think of it much like a wide area network application. So we've got all these entities out on the public internet that we're providing internal network access or network access to our internal network. And so we need to extend our internal network out to these AnyConnect folks. So the best application is to apply IP space design principles and carve out an IP block that you'll dedicate towards VPN clients. And again, needs to be appropriate sizing and planning based on that principle. And the fact that it's a maskable, routable IP block, it's got substantial benefits for the idea of route summarization and filtering outside of the ASA itself. So the best overall benefit is to not just think of it as a pool of addresses, which is what we'll apply, but think of it as a routable IP block. We need to be able to understand how to reach back or respond to these entities living out across our public internet. Other concepts, policy configuration. So split tunneling would be the idea that only some of the traffic from the endpoint is encrypted and sent towards the head end and de-encrypted to be utilized within our internal head end environment, and that the rest of it goes to the internet as normal. This is a pretty common tactic, but does raise security concerns. What if a bot has infected that endpoint and now has open access to our internal network via the AnyConnect tunnel, and we're not looking at that traffic per se? So we can choose otherwise and say no split tunneling. In this case, where it provides more security, can be a little bit more cause for help desk calls, in such that now once the AnyConnect SSL tunnel is established, all IP communication from that endpoint now goes through the tunnel to be evaluated by the head end and established and routed back out to even the public internet from the perspective of the head end. So one of the things that can be a challenge, and things that the ASA does a pretty good job of addressing pretty easily for that remote user, there are difficulties around establishing communications with local devices like their home printer, etc. So yeah, different concerns there. And then around that same area is split DNS. Sunset Learning provides a good example where we've got internal sunsetlearning.com and internal entities, our lab environment primarily, that names that we rather not divulge on the public internet. So we have an internal DNS server called sunsetlearning.com, and likewise a public DNS also representing sunsetlearning.com, and we have to think a little bit about that, the names that we want to be able to resolve when that tunnel is connected or not, and establishing that concept. And so split DNS, when the tunnel is up, I'm resolving names against sunsetlearning.com, then resolve against this internal server and not the public server. Also ahead of the game, so that's kind of a discussion, policy split tunneling concept, whether or not that's needed. Very environmental. There's many environments that through regulatory compliance, that's split tunneling is not a thing that can be done. So that would be definitely no split tunneling is the more secure implementation. Then further ahead, the need for, of course, a public IP address. The public IP address ultimately will have a DNS name applied to it. That DNS name, a record, is also going to be used for the identifying information within our certificate. So when people browse or use AnyConnect to connect to that FQDN, the certificate received matches that FQDN. A little bit more detail in the public IP. This can be a single static IP that's given by the internet provider, and can be just one IP, that we don't need a dedicated individual IP address to utilize for this aspect within ASA. It all depends on that provisioning and what other things that we might be doing with public IP addresses. But a single IP address is all that's needed. Dynamic, I think, would be an iffy prospect. So getting a not consistent, persistent IP address from the provider might be doable, but I would suggest would be problematic. I would steer away from something like that. And then open communication to that public IP address, TCP 443, of course, because this is TLS SSL. And then also, and not immediately apparent in the natural world of internet web browsing, but certainly with AnyConnect SSL tunneling, is UDP 443, which provides DTLS or datagram TLS. And the variation there is all still TLS, but now we're using a UDP header. And in fact, when UDP 443 is also open, it naturally transitions to using UDP 443 and DTLS for all the data communication, because UDP is just a nicer wrapper for the type of data streaming that we're trying to accomplish, and for a long-term, high duration, high traffic type of tunnel that we're trying to do, which is very different from web browsing in itself. So UDP 443 not required. If it's not open, all communication will still happen over TCP 443, but if UDP 443 is additionally open, data performance is distinctly improved. And then for the customers that we're trying to provide this access for, a consideration for being able to provide ping access for those users. Can we, if we're having problems, one of the common attacks, can we ping that name? And so, yeah, some consideration for that for the implementation that we have at Sunset, and our customers and AnyConnect users are mostly students. And so from their perspective, yeah, and more intelligent than maybe the average bearer will say. And so we allow ping access to our headend. Then again, planning ahead doesn't need to be done as part of the initial configuration, but thinking ahead, what do we want to provide? So the access policy, there's an effective default that once that AnyConnect tunnel is up, they can send any data in and through that tunnel to whatever device that they want to on the head end. Maybe we want to limit that. Who are these users? And we can create group-based policy around that and limit the access that that individual user has based on their group membership. And then there's also a natural effect of that we don't want translation to occur from the perspective of the AnyConnect client towards the devices they're communicating with on the head end. That's a default, but we can choose otherwise, so that we can actually translate that communication. Might be helpful for this idea of this unique routable IP block, that we can take advantage of translation tactics coming back inward from the perspective of the AnyConnect client, and dampen some of those effects. And then last but not least, and also kind of one of those, oh yeah, I forgot about that, that in all cases, regardless of how the deployment of the AnyConnect client occurs, that admin privileges are required to complete the installation. So that user needs to have elevated privileges temporarily to complete the install, and that's why I also recommend doing in not just the head-end deployment, but also the pre-deployment package, which in the case of Windows includes an MSI file to make that install and provide alternate means to do that install. Okay, about to dive into the demo. I just want to describe the certificate installation process. This will again be, I'll suggest universal to just about any device that I can think of in my head where I'm trying to obtain an identity certificate from a certificate authority. So in the case of the publicly trusted, yeah, the type and term of certificate with that provider that subscription, that fee. And then the next step is to generate a CSR, which will include the information that I want to have as an identifier and that public key value, and I submit that to the provider. And then the provider has signing certificates, issuer certificates, CA certificates that I need to add to the ASA or whatever environment that I'm trying to obtain a trusted ID certificate from, that I need to have copies of the signing certificates so I can validate that signature. And this is an ongoing process, and we would see the same concept done if you think about your web browser. It has copies of a large number of CA certificates so that when you're interacting with SSL-based web servers, that you have copies of those signing certificates to validate the received ID certificate from those web servers. So in this case, we need to have those installed on the ASA so we could validate the signature of the ID certificate that we're now about to install. That we can't apply the received ID certificate until we install the signing certificates to validate the signature. And that received ID certificate is bound to the CSR that we originally created effectively at step 2 there. So let's move on to the demo and show about how this works. Getting my screens in order. So now what I've flipped over to, I'm on what I'll call an admin VM that I have inside my Denver lab environment, and I've got an SSH session open to an ASA. In this case, it's a 5506. And I'm kind of a code freak. I'm running the latest and greatest ASA code, which is still supported on, I think, announced end of sale or potentially end of sale 5506 now. And I'm also running, I thought it would show the ASDM here, but I've got ASDM obviously running in the background. I might be able to see that version information. Yeah. ASDM 714. Going back to the command line because it's just a little bit easier to look at. I've got a very simple ASA config setup just to describe that this is inside our Denver lab environment. So I've got a public IP address that's translating to this private IP address. And this is my effective outside interface. I've got an inside interface with an IP, and I've got a management IP address. And very simple policy: outside security 0, inside security 100. Management not playing any part of a role other than my remote management capabilities. And there are no access lists in place. So this is a very generic config. I've got, of course, default static route. I've got a route to an inside network, but a very simple inside-outside configuration of an ASA. And yeah, pretty common as a VPN head-end concept. And then I've used and worked with an ASA and a router and switch. I'm very much a command line administrator, I'll say, for certificate administration, certificate management on an ASA, and I would suggest pretty much any other device. Really nice to have access to graphical management for so many reasons. We'll see that here pretty shortly. So take advantage of ASDM to get this certificate stuff done. So within ASDM, I've clicked on the configuration and device management, and now I've got the certificate management tree there, and I've got my ASA requesting a refresh on my authentication. And this is not what I wanted here, so let's delete that really quickly and apply. I sincerely thought I cleared this out yesterday. There we go. I think that's back enough to scratch. So this would be the typical look at an ASA. I, again, sincerely thought I had that cleared out. So in this case, no identity certificates established. We'll do an add here. And the first thing that kind of comes up in terms of the add identity certificate, and a thing that can be confusing for both from the command line perspective as well as what we're looking at in ASDM, is this concept of a trust point name. It's just an area in the config to establish this idea of certificate trust. It really makes no difference what that label is in terms of how the certificates, the ID certificate and the signers relate to one another, what that trust point name actually is. But if command line administration is also occurring, very helpful to establish a trust point name that provides some indication of what that certificate is going to be utilized for. Then we'll do, notice we have an import operation, which I'll discuss kind of at the tail end as we wrap things up here. In this operation, we're going to be doing an add, a new identity certificate. Notice we've got the opportunity here to generate a self-signed certificate, which is sufficient for initial testing, but not viable for ongoing production because it's not ever going to be trusted. And AnyConnect provides some pretty noisy, loud, big red box warnings about untrusted certificates, even if AnyConnect is configured to support them, that we still get those warnings. So not really viable for production. And of course, in terms of adding a new identity certificate, this is what the operation is, and you're not seeing any of this here. We're about to create a CSR. We're about to create a certificate signing request. And so we need to create a key pair. We want a distinct key pair. The public key pair will be submitted with the CSR, and so we're being asked about the key pair that we'd like to use. And in terms of looking the drop down, we've got the default RSA key, which is normally established on the ASA when we want to do SSH administration. So SSH compels us to create a key pair and a public key provided for SSH. This would be the default RSA key pair. And normally what we would do on a new CSR is create a new key pair and provide, instead of the default key pair name, the best practice would be to set up a new key pair name, provide appropriate key pair size for the CSR. In the case of Entrust, and I think most other providers, they'll expect a minimum of 2048 for the key pair size. It can go larger, but it really depends on what your vendor requires for that, and that we generate that key pair. And I've got ASDM set to show the commands that are used, again, making sure you understand that all of this is also viable via the command line. So that would be how to create a new key pair. I'm going to take advantage of the key pair that was used to create our publicly trusted certificate from Entrust. And so, and I'll again demonstrate how I established that on this ASA as I'm looking at it. And then we'll want to provide the identifying information. We hit the select field and provide the common name. So what we would expect listed in the certificate, in this case, will match exactly what my publicly trusted certificate provides, which is a star, an asterisk. So I can apply this now to multiple devices that can use their own unique identifier. The rest of the information is, again, for validity. Actually, there's not an OU, but there is an O in our certificate, which is Sunset Learning Institute. For the case of the providers, there's an expectation that you're going to be providing this minimal information in the certificate to provide identification information. So minimal fields are required. Oops. And in the case of our public certificate, we used our headquarters location in Ruston, Virginia. And then I say okay, and that certificate subject DN information is now added to their certificate. If I click on this advanced field, also, again, wish for better labeling on this, not immediately apparent. What we're looking at here is subject alternative names, and again, depending on the style or type of certificate, that would be a common attribute that we would list subject alternative names inside that certificate, alternate entities that we might be representing, maybe more than one device. Is a common attribute. For the STAR wildcard certificate that I purchased from Entrust, no subject alternative names should be listed there. So I'm clearing that out to make sure no SANs or subject alternative names are added. And now I do the add certificate. See the respecting information is going to create a new trust point. We see that it's going to use a particular key pair, the subject name for the CSR, and that the basic concept in the case of command line syntax, which is a little archaic, it describes this as enrollment. So we're enrolling and we're creating a CSR to enroll with a particular certificate authority. And now wants to save that to a file, and this is pretty common that the provider will want that needs a copy of that CSR, and it's only needed temporarily, only needed establish the file location here. Only needed for the initial receipt of an identity certificate. And so we don't need to maintain this file for very long. And then we'll open that up. And we see the contents of the CSR. And it's good, and again, a good practice to validate the CSR. I'm going to copy the contents here and open up my web browser and just do a quick search on SSL tools. And again, my tactics, the first site that always shows up is this one. One of my favorites are SSL certificate tools. And they have a handy CSR decoder among some other friendly tools there, and I'll copy in the contents of that CSR. And I pressed enter, didn't need to, and it looks, oh yeah, so good that I validated the CSR. I'm missing my organization information, so let's go back. I can't edit this CSR, so I'll have to delete it and add again. And so, again, a nice real-world example of things that you'll want to do before submitting the certificate to a provider. There's no particular order to these in terms of the creation of the CSR, just the identifying field information. And I think I have everything in there correct this time. Let's remove the SAN. And then we'll do this operation once more. And now I've got my organization name in there, and this CSR is now safe to submit. Now, kind of going back to our steps here, just to review. Submit CSR to provider, and then add the signing or issuer CA certificate. So in terms of the normal process, in the case of Entrust specifically, they announced to me via email that they provide, that they established that I'm authorized to obtain said ID certificate. And of course, they've already digested the funding needed for that, and announced to me now, here is now my ready to go identity certificate that I requested and that I've paid for. And as part of that process, I browse back in and they step me through, before you try and utilize your ID certificate, you need to obtain copies of our signing certificates and provide me the means to easily download and obtain those. And then, of course, the next step would be to apply the ID certificate they ultimately submitted to me. So let's step through that process. Back on the ASA, we've got our CSR in place, and the next drawer down we have is CA certificates. And I'll do an add operation here, and I'll provide a label and then a little bit of a description. We're going to install from a file. So we received a copy of the Entrust root certificate from Entrust, and I'll browse out to that and apply that certificate. And then in the case of Entrust and in many other public certificate providers, they apply subordinate or intermediate concepts, and that needs to be applied also. Ultimately, the Entrust intermediate is the entity that signed the ID certificate that I'm about to install. So we need to have trust for both the subordinate or intermediate, L1K as it's listed here. L1K was provided an ID certificate that was signed by the root. So in this case, not immediately apparent here, I would not have been able to install the intermediate certificate without having previously installed the root certificate. The root certificate signed this intermediate certificate. And so now I've got both of those in place. Notice this doesn't require any specific apply in terms of adding that trust, but pretty good idea to go ahead and do a write at various stages through here now that I've established this trust. And then I go back to identity certificates. I've got my pending CSR in place. Notice it shows this pending status. And then I click the install on that selected CSR and browse. And in the case of Entrust, they don't really distinguish what their ID certificates are being used for. But yeah, we see this indicated as a generic server certificate. So it could be as easily applied to a web server as to an ASA. And we'll install that certificate file. We see the commands related, and the import successful based on the fact that I've got the signing certificates already installed and trusted. So the signer of my ID certificate is added as a CA certificate and now trusted. Okay, now moving along, kind of going back to my slides here. We've applied the received ID certificate to the CSR. Let's move through the next steps to actually generate a VPN configuration. I'm going to take advantage of the VPN wizard that's in as part of ASDM. It provides a wonderful starting point and gives me other things to talk about as we're moving through the process. First step in the setup wizard is to create a connection profile. For my own purposes, I often think about this as the method of, or the means that we're describing ultimately for the users that are going to be connecting via this access. So in this case, it really just describes that we'll be using SSL TLS for this connection. AnyConnect is my acronym there. We'll do next. We've got the opportunity to select an interface. Yeah, typical application is against the internet-facing interface. The connection setup establishes what protocols that will be running against that. For remote access VPN, IPsec is now easily supported, uses what they call IKv2 as a connection method, a little heavier duty and also requires additional licensing. Typical tactics is just use SSL. And in this case, where they say SSL, what they really mean is TLS. And then the device certificate. So our ID certificate, wildcard certificate that we established and planted, and you can see that there is a manage button here, and we can do some of those same add operations, but we're missing the CA screens and some other stuff. So very helpful to establish that trusted ID certificate before running the wizard. And so made that easily available via dropdown. This also easy facilitates the idea the certificate will expire in a couple of years in our case. In all cases, expire eventually, so renewal has to occur. And once we get that renewed ID certificate, it would show up in this dropdown. We could apply it easily to our already created connection. Then client images. So again, as part of the requirements, I mentioned that you would need to obtain the PKG file. And I have got a copy of that here. Excuse me. And then I'll upload that file, and that will get added to the flash of the ASA that I'm working on. This is an absolute requirement, not optional. The ASA and any head-end device needs a copy of the PKG so it understands the capabilities of the AnyConnect client support that it's supposed to provide, and also provides the means to automatically install the AnyConnect client. Collect myself here a little bit. This next step allows us to provide means to do initial authentication. We've got the capabilities easily on the ASA to integrate this with an external radius server, like the Identity Services Engine, and also they show NT here, but it should not be included in the wizard because it's really not supported any longer. Today, if we want to integrate with Active Directory, we would use LDAP, and we would establish the ASA as an LDAP client to an Active Directory server, and we could authenticate against our Active Directory user database there, if you will. In this case, again, a nice, easy starting point is that we can create our own user database locally on the ASA, the local server group, and we'll create a user ID here. And add that. Notice that this is being added to the already existing admin user ID, but it doesn't have the same privileges. That's not immediately demonstrated here within the wizard either, but the new VPN GP user that I just added is added as privilege level 2 in the running configuration and doesn't have the means or the privileges necessary to be able to access ASDM, even though we're using that same common database. So different privilege levels, even though they're not being described there. SAML is now also supported. This is newer code concepts and kind of a nice alternative to consider if you're, for example, an Office 365 user. Office 365 provides SAML type integration, and we can authenticate against that cloud-based concept using SAML. Security Assertion Markup Language is the acronym for that, and widely supported against many entities. Single sign-on is the other environmental concept that you'll hear with SAML that also provides that concept. So just again, in that step, we're not going to do SAML here. And now our address pool. This is going to be the, again, the addresses that we'll be handing out to our VPN clients as they establish a connection, providing them the means to interact with our internal environment. And for the planning ahead, where we will have wanted to allocate an effective subnet for this aspect. And then again, to some extent, to the benefit of the split DNS concept, and again, an optional in this particular scenario, a DNS server that will want our VPN client connected users to resolve against, and then internal domain name that will establish for them as well to make name resolution a little easier. And then the opportunity to create a quick network address translation policy, in this case a NAT exemption, which will create a NAT rule on the ASA and prevent translation between the pool that I just created, which we'll go back to. So this space, these addresses, reaching into our internal network that I'll use. It's not effective default, but yeah, commonly done is we don't want translation to occur there. And I'll want them inside as the directly connected interface to our internal network. And then I can add other networks as needed that I want to provide this non-translation effect to. And I'll add my little internal test network. I'm borrowing Marty's lab environment this week, so we'll call that the Marty net. And that is this address space. So we'll want to not translate to the inside network, and we don't want to translate into the Marty net in my small environment. And so it will create a little NAT policy to support that. And then just lets us know how we can deploy the AnyConnect client. We can use the pre-deployment and pre-install it, or we can use the web launch. We'll use a web launch in our example. And then shows us the general summary config of everything that's created. So again, hopefully easy to see how ASDM makes this kind of a snap, but all doable on the command line if that's the desired approach. Okay, config is in place. Yeah, one of the things I like about the wizard running on this somewhat new version of the ASA and ASDM in combination. As soon as we get done running the wizard, it takes us immediately to the screens around the configuration that we just performed. It takes us to AnyConnect connection profiles. Lets us see that we've turned on AnyConnect client access. Based on the outside interface, we're going to allow SSL and DTLS, this is the UDP 443 variation, but not IPsec. Only SSL TLS. And then lets us see another little policy configuration. This does not show up in the wizard, but just some awareness now that we do not need to create access rules for the traffic moving through the tunnel with this checkbox turned on. So this is a quasi default. We can choose otherwise, and says, yeah, this could disrupt traffic flowing through the IPsec SSL tunnel. And says to avoid that, make sure the VPN traffic is explicitly allowed on all required interfaces. So this would give us the opportunity, if we wanted to create maybe more of a higher security profile, that we could turn this checkbox off and now create access list statements against our outside interface to describe the traffic that we want to allow through the tunnel. In this case, I'm going to take advantage of this bypass. And so I don't need to create explicit rules. This will implicitly allow any traffic moving through the tunnel to proceed through the ASA. And then for the multiple groups that we might be wanting to provide, this is a nice checkbox turned on by default. They'll be allowed to select the connection profile, which will tie them to a particular group policy that we see listed below here. And we see a couple of defaults that are provided as templates, and this new one that was created by virtue of the wizard. And if we edit that, we can see that this provides the means to determine how we want to authenticate these groups of users, the pool of addresses they'll be getting, and their ultimate group policy that they'll be applied to them. And the group policy would give us the opportunity to determine whether or not we want to apply split tunneling. For our example, I'll leave split tunneling turned off, but this is where we would set that. And then I can manipulate that for particular groups of users, and we could see some of the other settings applied there. About the only other thing that I do in a common implementation as we look through here is the AnyConnect profile. And there's none in place by default, but this provides some nice benefits for our end users. If I create a profile, this will get stored on the local flash or disk of the ASA. I can tie this to a particular group. If that's helpful, I'll go ahead and take advantage of that here. And then when I edit this profile, I'm given lots of options for AnyConnect client behavior from the perspective of the endpoint. So whether or not auto update is enabled, for example, other preferences. And in this case, what I'm going to do is provide, once the AnyConnect client is installed, where they don't have to type something in the connection box to reach the head end that I'm trying to describe. So more than one can be added here. But just kind of a nice little customer add-on for my users that now they don't have to type anything when they open the AnyConnect box. And once I apply this, this will create a new XML file. And this XML file, where it's stored on Flash, where I can review and edit it, is also provided with the AnyConnect deployment if we're doing it from the ASA itself. We'll see an example of that coming up here pretty quickly. And I got a little error here. This is an artifact of new ASDM, I'm presuming, where it doesn't like this IPv6 address pool that I don't have. So everything's fine. There's just a little error. Good time to save config. And let's just do a quick run through of now what we have on our ASA. See our new pool added there. We can see the new NAT rule that's been added. In this case, yeah, looking specifically, it created objects to support this, but the pool of addresses that were created and then getting into the destinations basically says don't translate. If you're moving between here, leave it to that same and don't translate that address. So that new NAT policy's been added by virtue of the wizard. I can see my certificate information, and yeah, one of the necessary evils of, I'm scrolling back up here now, that yeah, a substantial amount is added to the command line configuration as a result of adding trusted certificates. And so I'm seeing all of those in place here, my signing certificates and my ultimate ID certificate all demonstrated there. And then finally, the VPN can set up where I'm seeing, again, the SSL variations that were set up against, in particular, the outside interface, and then the web VPN configuration enabled on the outside, using this particular AnyConnect image, using this particular XML file. and then local user database. We can see admin with priv 15 and the new user with no priv, so hidden default there is priv 2. And that's about all that's really added to the config in support of this. So pretty, the certificates obviously adds a substantial amount to the config, but the VPN config itself is pretty easy to deal with. So running a little over time here, so we'll move right along and establish a connection. This now is the VM I have here in my home office. And we'll browse to the FQDN of the ASA headend that I provided. And again, this is effective defaults. What we're looking at here would be called or could be called a portal. And this is, I didn't have to do anything to create this, so the ASA did this all on its own. But this is also customizable, that I can put my own logo, color scheme, other variations, messaging that I can put all within this logon portal. Again, provide some convenience for my users. I can see that I'm given the opportunity to select a group / connection profile. And I'll put in my new user ID and log in. And that did not work. All right, let's go back and look at my configuration. Try that one more time here. There we go. Just a typoed that when I created the user. And next page that comes up, again, this is also being provided by the ASA. This page is also customizable, but just provides some nice steps along this. I love this little instructions page where it describes for the end user the steps that they're about to proceed through, gives them an idea that they'll need administrative privileges, and lets them know that it doesn't automatically launch the AnyConnect client, that they need to grab that out of the start menu after the install is completed. So just walk them through the nice steps there. I'll go ahead and do the download for Windows. We've got web deployment packages that we can provide for Mac or Linux, and those would be automatically determined based on how we establish our browser connection. And we could select otherwise if we needed. And go ahead and save that over the top of what I've already downloaded. And we'll go to our download file. So notice that, yeah, we're actually getting a .exe that I did not add to the ASA. It's automatically extracted from the contents of that PKG file. So the PKG file provides this executable. No reboot required, which is nice. Let's make this full screen just to provide something easier to look at here. And then within the start menu, I should have AnyConnect. And the remember the XML file, as part of that AnyConnect profile configuration I did on the ASA, that I pre-configured a connection entity to show up in this box. Let's see if it works. When I did this yesterday, it had a little bit of a problem, and I wasn't able to troubleshoot it. So I'll try it one more time. and then give up and troubleshoot that later and do what I know will work, which is the full FQDN. And then now given the opportunity for the full AnyConnect login, and my tunnel is established. One of the things that I missed here that you'll notice is I did my initial browse and this AnyConnect connection, no certificate warnings. Probably good to kind of take a look at what actually was provided in the browser here, if I can still look at that. And I can see the certificate based on what I established on the ASA side. This star.sunsetlearning.com. The issuer is the L1K Entrust Cert Authority. You can see the contents of the certificate. And then kind of cool within the Firefox browser shows me the signers. So here's the L1K that was signed by the root G2. And here's a copy of the root G2 certificates. These certificates, although they were installed on the ASA, they were not provided by the ASA. The ASA only provided this one. So the copies of the signing certificates in this case are maintained by Firefox itself. Other browsers use the Windows certificate store, and though copies of these same certificates are within the Windows Trusted Certificate Store as well. Both of these have a long duration lifetime. So let's see if the tunnel works now. I can see AnyConnect is up. I can see by opening up the details there that his tunnel is established. It's used DTLS because I have UDP 443 open all the way through. And let's see if I can reach my entity on the inside. Yes, there we go. It theoretically. Yeah. And then Marty's internal router that we provide for his Racksonal 2811. But yeah, successfully able to reach across the tunnel into an entity beyond the ASA on that internal network, and all is well there. If we go back just to take a look at the ASA itself. I should see a couple of things within this. As I do a show route, I can see that based on the pool allocation that a new route was added to the 5506 route table to support reachability back to that particular AnyConnected client. If we were to apply some dynamic routing like ERGRP or OSPF, we could redistribute this route or summarize it or any of a number of things. All depends on the positioning of that ASA. That may or may not be our internet gateway. So we could have the opportunity to describe that route to other routers, if you will. Fine. And there we can see the VPN GP user logged in, assigned IP address. Also shows a little bit more details about the algorithms in place. So using the AES symmetric encryption algorithm, and that's being used across DTLS. So we've got actually in place now two tunnels, one that's based on TCP SSL and one that's based on UDP SSL or TLS, if you will. And we're also applying SHA hashing algorithms to ensure integrity of that data. See login time, how long I've been active, inactivity, and other information on those details. And I think that is all I had for demonstration on the ASA, adding a publicly trusted certificate and utilizing that for AnyConnect VPN. So much more creativity can be done there, but ultimately the simple task without having to provide a bunch of creativity and whatnot is pretty easy to do. And hopefully I provided some nice information on some of the PKI aspects helpful, where that can be, again, cause for anxiety. Hopefully I've dampened some of that a little bit. And so with that, I'll effectively wrap up. Oh, I know one of the things I forgot. Let's go back here real quick before I forget, because I think it is important. Let's go back to my management PC, and we'll take advantage of ASDM here. I'm going to go back to device management and our identity certificate. I'm not sure what that's about. We'll see this valid certificate in place. And one of the important options here is to export. And we've got the opportunity to export this as a file. And whatever extension required there, it's not super important. The package is important, and this will create a nice bundle of the ID of the key pair. Notice it says private key, so the key pair is added to this file. The ID certificate that I just obtained and the signing certificates. The only thing that you need to know is the password that is assigned to this file. And I'm not sure why I got an error there, but this would now allow me, when I come back and do an add, where I can now import and provide that same passphrase and that file name, and voila, everything will be restored with respect to my certificate-based information. Very handy in the event that our ASA blows up for whatever reason physically. The other very nice thing to do after this, and ASDM and the command line both provide this. And while we're in ASDM, we'll take advantage. So I went to Tools and Backup, and I can provide a particular file name on my own. Oops, I didn't want that file. And lets me select all those same things. So keys, certificates, and if you notice down here, the web content. So one of the things where I mentioned about customization of those login portals, none of that shows up in the running config. So copy run start doesn't give you that archive of the things that we created within those portals, but this backup operation does. So yeah, sure, we get the running, we get the startup, we get images, we get keys, we get certs, and then we get anything that we've done through portal configuration through this backup. So I would recommend both the export of the key pair, the export operation that we did for the individual ID certificate, and this backup where AnyConnect VPN is used on a production ASA. Both of these should be done pretty much ongoing, and certainly anytime we're doing certificate operations. And yes, I was saying wrap up and back up and wrap up was my last bullet, so I just I just did that. So yes, wrapping up. And I see El Rossi. I think you're the only one logged in there. Opportunity for questions. Anything that I might be able to provide some more details on there?
Just a quick question on that.
Sure.
You just pulled that back up with all the information. Can you do a restore?
Yes.
With all, and it'll include everything?
Yes. That's exactly what this is for. So yeah, along with the backup there, see that we've got the restore. We just have to specify that file name.
Wow. Okay. That's really nice.
Yeah. I think they introduced that. It's a pretty new feature. I think they introduced that in 9.8. Yeah, 9.8. So, but and again, there's different toggles, but the same capability available in the family as well. It's not exclusive to ASDM.
Okay, and I really, for all the classes I've taken, CCNA security and all these other things, your explanation of the two identity certs and the CA certs is the first time I actually understand.
Is that right? Well, that's that's awesome. Well, yeah, there you go. I've been kind of gunning for this within some. I'm sorry, El Rossi. What's your actual name? Lewis, thank you, Lewis. Have you sat one of my classes before?
No, I haven't.
Okay.
First time.
Yeah, it comes up a lot, this anxiety around PKI, and I get it. And I get why there's anxiety around that, because none of the vendors really apply the terms consistently, but you see these same basic patterns. Anytime that you're applying certificates at all, it's the same basic stuff, regardless. Windows Server, firepower, yeah, router. In fact, the head end that I use in production at Sunset is actually a 2950. It's a 2950 router, not an ASA. We're using VRFs. So, but the same basic principles apply across the board, and it's just not immediately apparent what the heck is going on there. And I think our technology world, the device vendors, don't make it any better, honestly. So I'm glad that you got a little bit more out of that.
And then that install order is always going to be the same: root, intermediate, and then the actual certificate itself.
Yeah, it's all about the signing, right? That I can't trust this new certificate until I trust the signer.
Right.
And that I have to, in this case where it's not also apparent, right, where I'm adding the CAs, right, that I'm telling the ASA to trust these signers, right? I can't install the L1K until it trusts the root, and I'm implicitly, by installing these CA certificates, telling the ASA that trust these signers. And you'll see on other vendors' devices, I know Firepower does this, where they have a healthy list of already trusted root signers that are already in there. ISE does that as well. ISE has got a healthy list of trusted root CA signers, just like a web browser. So ASA is kind of unique in that regard. So,
well, thank you so much. I really learned a lot today. I appreciate it.
You're very welcome, Lewis.